2.5, transformations of functions preparation. All right. So the graph of y is equal to negative f of x is the graph of y is equal to f of x reflected about the x-axis. Cool. So let's see this. If you look at the chart above over here, you see the x values, and if we plug it into the equation, it spits out the y values, right? The f of x right here, which is really kind of the y. And what that would do is that would give us a graph something like this. So this is the base or kind of parent graph. Okay, now let's see what happens if we transform this. Now I did say it's going to flip it across the y-axis, and that's correct. And we can prove it. We can plug it in because we just flip the signs, right? So if we plug a -2 into this negative x, that gives us a +2. -1 will give us a +1. 0, +1 will give you a -1, and +2 will give me a -2. And if I plot all those points and I graph it, so since -2, 2 would be right about there. We'd have one there, we'd have one there, we'd have one there, and we'd have one there. And if I draw a line through all those, sure enough, that flipped it along the x-axis. And this x-axis right here. So that worked, right? Okay. So let's try another one. So we're going to use the graph of f of x is equal to x squared to obtain the graph of g of x is equal to negative x squared. Okay, so our base graph would look something like this. So we would graph it out, and roughly it would look something like this, and it would look something like, oh dear, something like this. Okay. Now, if this is correct, by just sticking that negative in front of it, the x squared, it should flip it along the x-axis. So let's plug it in. So, whether I plug in a -3 or a +3, okay, I should end up with a -9. If I plug in a negative or +2, it's going to give me a -4. And if I plug in a negative or +1, it's going to be a -1. And if I plug in 0, it gives me 0. So I plot those points. Let's see what we get. We have the 0, so that point's the same. We have these points. We have these points right here. And we have the final one, which is 3 and 9, which is here and here. Okay, so from there, it should look something like right there. Okay, so it did. It actually flipped along the x-axis again. Use the graph of f of x is equal to x cubed to obtain the graph of g of x is equal to negative x cubed. Okay, so we put a negative in front of the original equation, so it should flip it along the x-axis. Okay, so let's plug it in. So we plug in a 0. 0 cubed is 0. -1 cubed is -1. -2 cubed is -8. 1 cubed is 1. 2 cubed is +8. Okay, so the original one, if we're just using these points over here, we're just using those right there. So we have -2. So first we have 0, 0. So I just put that right in the middle. So we have -1, -1. But we also have a 1, 1. And we have a 2, 8, which is right over here. But we also have a -2, -8, which is right there. So if I draw a line through here roughly, oh dear, very roughly, it should look something like this and this. So that should be roughly the shape of the original, right? Now, so that's the parent function or mother function. So if we put that negative in front of the x cubed, we should flip the entire thing. And let's see, so here we still have the 0, 0, so it still goes through the center. We have a -1, let's see, but we flip it, so all these signs are flipped because of this negative right there. So that turns into a positive, that turns into a positive, that turns into a negative, that turns into a negative. So we have -2, +8. So -2, +8 will be over here. We have -1, +1 there, +1, -1, and then finally we have right here positive 2, negative 8. And if I draw a line through all this, hopefully I pull this off this time. I'm going to do my best. Oh dear. Something like that and that. And sure enough, we flipped it along this x-axis, right? Let's try another one. So we have the original square root function. So I'm just plotting these. So we have 0, 0. It starts right there in the middle. Then we have 1, 1. We have 4, 2. 4, 2. We have 9, 3 right there. So I try to draw a rough line through all these. It should look something like that. So that's my parent function. Let's try the other one. So now we say square root, negative square root of 0 is 0. Square root of 1 is 1, and then we put the negative in front of it, which gives me a negative 1. Square root of 4 is 2, put the negative in front of it, negative 2. Square root of 9 is 3, put the negative in front of it, we get the negative 3. Okay, so let's see what we get here. We get a 0, 0, right there in the middle. Then we have 1, negative 1, which is down here. Then we have a 4 and negative 2, and then we have a 9 and a negative 3. And sure enough, when we draw a line through all this, we end up with something like that. So again, it actually flipped along the x-axis. This x-axis right there, just flipped it. It flipped it, right? All right, so now we're going to use the cube root of x to obtain the graph of g of x equals negative cube root of x. So it should theoretically just flip along the x-axis. Okay, so the parent function, I'm going to just plot these points right here. So we have a 0, 0, which starts off in the middle. Then I have a negative 1, negative 1. I also have a 1, 1. I have a negative 8, negative 2. So negative 8, negative 2, way over here. And then I have 8, 2, which is way over there. So it should be something like this. And it should be something like that as well. Okay. Now, what about this? So we plug a 0 in there. Cube root of 0 is 0. And we put a negative in front of it, still 0. Cube root of 1 is 1. We put a negative in front of it, it's a negative 1. Cube root of 8 is 2. Put a negative in front of it, gives me a negative 2. Cube root of 9. Oh, I messed that one up, didn't I? Let's just leave that out. That shouldn't be there. That should be a 27 for it to work out nicely. We can do 27, but it's not going to fill in the graph anyway, so these aren't going to fill in the graph. Let's just leave that out. Okay, so we have 0, 0. We'll put it in the middle. We have 1, negative 1. So 1, negative 1 is right there. We have 8, negative 2. 8, negative 2 is way over here. So let's kind of fill in the rest of this graph. I could have done a better job on this. Let's plug in a negative 1. All right, so if I plug in a negative 1, so plug in a negative 1 right there instead. That would be the cube root of negative 1 is negative 1, and a negative negative 1 is a positive 1. And let's plug in a negative 8. Cube root of negative 8 is negative 2, and a negative negative 2 is a positive 2. Okay, so we'll just finish this out over here and here. Okay, excellent. So we draw a line roughly through these points, try to smooth it out a little bit, and this is what we get. And sure enough, it did in fact flip along the x-axis. So when we put this negative in front here, it flipped the original or parent function. So if you memorize the parent functions, you can actually use them to do closely related functions because if you understand transformations. Let's try another one. Okay, so I'm going to start off by graphing this. So just by plotting these points right there. So it looks something like this. Whoa, cut off. And something like this right there. Okay, so just plot the points if you want. Got the negative positive 1, and negative positive 2, and 3. Didn't do a very good job that time. Okay, so let's try the other one. So I plug in a negative or positive 3, I get a 3. I plug in negative or positive 2, I get a 2. I plug in negative or positive 1, I get a 1. I plug in a 0, I get a 0. Okay, so it should be the 0 right there, and then whether it's a negative or positive 1, I get a negative 1 because I put this negative in front, right? So that should spit out negative versions of that, right? So I plug in absolute value of negative 3 is positive 3, which I'm going to flip to negative because the negative in front of it. Absolute value of positive 3 is 3. With the negative in front of it, you get negative 3. And the same thing's true with the 2 and the 1, right? So we end up with this shape right here. Hopefully I can do a better job graphing this. We'll see what happens. Oh, not really. And that right there. Excellent. Okay, so in fact it did flip across the x-axis, this line right here, whenever we put a negative in front of it. Okay, so when the graph y is equal to f of negative x is the graph of y is equal to f of x reflected about the y-axis. Now notice this is different. We're actually plugging a negative x instead of an x. Okay, so if our original linear function was this right here, and I'm just plotting the points they gave me before very roughly, something like this. So I'm just plotting that right there. So it would have been a point right there, a point right there, a point right there, a point right there, and a point right there. Okay, now what happens if I plug a negative x into that, okay? Well, that would simply give me a positive 2, a positive 1, a 0, a negative 1, and a negative 2. If I plug it in. And if I plot that, see I still have 1 at 0. But when I plug in a negative 1, it gives me a positive 1 over here. There we go. So I'm just plotting out the points. And when I draw a line through it, sure enough, this should reflect across the y-axis, roughly reflect across the y-axis. So this y-axis right here, this line right here should reflect across that. It should be symmetric. Now some of you might remember that when we plugged in a negative in front of the x, it also flipped across the x-axis. That was earlier, right? And sure enough, it did. Actually, reflected it across both. It reflected as here to here, right? Or you could think of it in other terms. You could reflect it across here to here, right? And both are true. Okay, let's try the next one. So I plug in a negative. Now in this case, because this is an even, it's going to look a little different. So your parent function, I'm just plotting these points right here. All right, so we have a, point here, and here, here, and then finally here and here. And if you just memorize these parent functions, you'll be able to start graphing these really quickly, probably better than I will. It looks something like that. Okay, so let's come up with some new points. Now, I'm saying a negative squared. So a negative 2 squared is 4, and a positive 2 squared is 4. They're both 4. A negative 1 squared is positive 1, and a positive 1 squared is also 1. And 0 squared is 0. So I have these points. So what does that really mean, right? Well, what it means is, if I graph this, I end up with the same thing. And if I wanted to, I could have added another point. I could have just as easily added as many points as the previous one. Oh, no, I'm actually adding more points. Well, if I did add another positive or negative 3, then I would have gotten a 9. Okay, so it looks like, in fact, I end up with the same graph, right? So, and the way that is because it's symmetric with respect to the y-axis. It's spun around the y-axis, right? So this is the y-axis, and it's spun right across there, right? It's a mirror image right across there. So this one actually held up. So whenever I put a negative into the x, right, and then I squared it, I got this. Now notice this is an odd. You got a 1, right? This is an odd power 1. And then over here, you got an even power 2. And it looks like this, okay? So we're going to go over that pattern in a little bit.